Hi guys, this is Dr. Callahan for Algebra 2 Semester 2. How are you guys doing? Welcome to week 16, Thursday. Go ahead and pause the video and answer the following questions. Okay, so for the third question, it's kind of like catchphrases. Okay, so what are some of the catchphrases that you guys see there for your third one? The first one I give you is pretty please. So that's the first one. Do you see any other ones? Yes. Big if. Yep. It's a big if, right? Yep. This one, anybody else? Yes, go ahead. Just shout it out. You know what? Nobody figured this one out, including my GT kids. Next to nothing. Absolutely. Good job, Marley. I was like, nobody in my calculus kids figure out. They figure out everything else, but that one, they were like, next to empty air, but nobody said next to nothing. That's good. We were a little bit confused with this one. It's like, we thought it was like 6 ones, 6 others. So it's like 1 to another. Like that's what we thought it was, 1 to another. I mean, this one's easy. It's like top hat, back door, staying up all night. This one was an interesting hop backwards. Your time is up, pipeline. This one's a good one, 3 blind mice. My pen stopped working, so let's try another pen. Anyways, I thought that was kind of like an interesting little thing. This one we were not sure. We thought like marry to marry or to marry some of marry or like marry to marry. We weren't sure. Does anybody see any others? I don't know, some people really enjoy these like little creative things for brain teasers. It's always nice to keep your brain fresh. All right, so I'm gonna have you guys go ahead and get started on this one. So go to the Padlet, we're gonna do this first. And happy Cinco de Mayo, it is actually today, but also on Sunday is Mother's Day. So my question for you guys on this Padlet is, after watching the history of Mother's Day, which I'm going to show you guys in a second, what are your plans for your mom on Sunday? How are you appreciative of your mom? And what's another holiday that you should celebrate that is currently not a holiday? So do you think there's any holidays that we should perhaps make it into a holiday, even though it's not one, but you feel like there's some value to it? So go ahead and go to that QR code and respond. But before you do that, all right, so if you're done with the Padlet, we're going to go ahead and move on. Just to give you a little bit of data, because I'm also a prop and stats teacher. Mother's Day spending is a $23.6 billion industry. On average, people spend about $186 per person on Mother's Day on jewelry, dining, flowers, clothing, spa day, etc. If you are a stay-at-home mom, it's not because you don't earn a salary. There's a lot of places that have determined if you're a stay-at-home mom, your average salary with everything that you do, like chauffeuring your kids around, cleaning, being a daycare provider, a chef, etc., is about $143,000 annual salary based on everything that you do on a daily basis. Some of the things that people purchase, it seems like greeting cards are the leading ones, followed by flowers, dinner or brunch, gift cards, clothing, jewelry, etc. So next what I'll have you guys do is take a look at your final schedule. So you guys know that you guys are in my 3rd period class. I will see you guys on June 6th, which is that Monday at 7:45 a.m. Your test is a time test. It is a high secure test. You'll be giving me your backpack along the walls. I will allow you to come in with a 15-minute difference, but it is expected you be here on time, you guys, okay? Anything after that 15 minutes, you will not be able to take the test and you'll get it incomplete, but you can make it that up upon being a senior the following year, and you make it up like, when you guys return. But it is a time test. So if you're like consistently late, do not be late on June 6th, which is that Monday. Your classes are only 2 hours each for your final, so you guys get out 2 classes a day at 11:55. You can go home or go to Sonic's, or do something else. All right, so we're pretty much almost done with everything. We are on the 5th of May. And so next week's week 17, 18, and 19. And then week 20 is your finals week, and your final starts on that Friday. So we're kind of towards the end. Safety grade is still at a 75%, so just keep that in mind. And I do have your grades updated. It's also posted on Teams. Common district final. Anybody who's enrolled in Algebra 2 in the 13 high schools in Washoe County School District, you guys will be taking exactly the same test, just like you did in geometry last year and the year before that for Algebra 1. It is a culmination of free response, fill in the blank, multiple select. Multiple select just means there's 2 or more correct answers. So if you select one of the answers, but you didn't select the other answer, you'll get marked wrong. So you have to select more than 2 answers. You'll have a Scantron, your computer will grade it, or my computer will grade it. It is a high secure test, so when you guys walk in that day, your personal belongings will be alongside the walls. You don't have access to your backpack and your cell phones. There's no cell phone, iWatches, technology, AirPods of any kind. It is a testing violation. It's 15% of your grade. Safety grade is a 75%. You need, after the final, a 60% or better to pass. So we'll do our study guide on week 18 and 19, and you'll take your final on that Monday of week 20 at 7:45 a.m. Okay. Your grades are as follows, 5, 5.5, 6, 7, 8, 9, 10. You guys all know how this works, so I don't feel the need to repeat myself again. And of course, you guys have your YouTube channel, which, I always check on a regular basis just to make sure that I didn't forget to upload the video, because sometimes it does happen, and in which case I will change it. There are 74 videos. And so yesterday was Wednesday. And if you look at it, week 16 Wednesday is already there. So you have everything already going for you. If you look at week 16 Monday, it is like 3 hours because I literally forgot to stop the DM video. So I just video recorded all of 4th period, 5th period, and 6th period. And I didn't have time to go back and edit it. So if you're like, why is this going over to province stats? That's the reason why. But I'm going to go back and change it over the summer. So in case you're curious, yeah, it's 3 hours. All right, you guys. So yesterday was Wednesday. What we did yesterday was the following. You guys had your quiz, but your assessment wasn't on Math Excel. It was simply just on Introduction to Logarithms on a Desmos. So as long as you completed a Desmos, then you should be good to go. We also went over a few of the movements because we talked about this. We used our calculators and whatnot with a few of the application problems. Gentlemen, can I have you guys lower your voice, please? Thank you. And we also introduced how to solve equations using E. And also with your calculators. So today is week 16, Thursday, and our objective is on compound interest and E. Your activity is you're going to continue with your guided notes on the compound interest and the formulas used. I'm going to have a quizzes for you guys. So you need 2 things. You need to have a TI-84 calculator. You need to have highlighters, which is already there. And then an iPad if you need to grab an iPad if you don't have your cell phone with you. So come on up and grab those 2 things, but iPad if you don't have one. And you really do need a calculator today because we're going to be graphing with E. So if you don't have one, make sure you come up and grab one. On your final exam, you are allowed to use a TI-84 calculator. So I actually should probably put that in your PowerPoint as well. So give me 1 second, what I can do here. So on this part right here, I just basically said, what can you have on the common district final? So on that Monday, you can have the following. 1, you can go ahead and have your TI-84 calculator. You can definitely use that. You're going to have an answer Scantron, and you need to make sure it's your name, because if you sit down on a Scantron that is not your name, it's great that you're going to take the test, but the computer is going to give the other person your grade. And I'm not checking for your name. I'm just going to grade it by a computer. So make sure it's your name. You can have a number 2 pencil. And because this is a Scantron, make sure you guys don't use pens, okay? And you can have a bottle of water. So you can bring in like an entire spread of Domino's pizza on your test, okay? So bottle of water. So in addition to that, you also have a test book, and you will be assigned to a specific number of that textbook. And whatever I give to you, those tests have to get back to me at that same number before anybody is released. So before you leave, I have to do the count. You guys have done this before in your geometry and then also your Algebra 1 class. It's the same procedure, but those are the things that you can have to use on the day of the final. There is a formula sheet inside your test book. There are absolutely no notes, electronics, and you cannot phone a friend, okay? So unfortunately, you can't ask your buddy next to you, go, hey, where's the square root button on my electronic calculator? Can't do that, I'm sorry. All right, so we will go ahead and get started then. So I'm gonna have you guys go ahead and turn over to this page of your guided note. Does anybody need another copy of the guided note? Anybody else need a copy of this? Copy? All right, so today we're going to go over the different type of formulas. So we've already been through exponential growth formula. We've talked about the exponential decay formula. The only difference is you add and you subtract the rate of change. Next, you have the compound interest. This is the one where things are like quarterly, which means 4, semi-annual, which means there's 2, or if you do daily, weekly, etc. And then yesterday, I went over the continuous compound interest, which has the letter E. This is the one that if you're putting your money in a bank, this will give you a lot more money than this one, obviously. And so those are the 4 different formulas that we've used so far. Today, we're going to kind of like apply that to each specific question, and you have to guess which formula you have to use, okay? So with that said, let's go ahead and get started on this one right here. So day 6, 3.1, compound interest and E. So if you're curious as to how do we get E to become a number, E is actually given to you from this formula. You start off with 1, then you add that to the fraction 1 over 1, and then you add to the fraction 1 over 1 times 2, then you add the next fraction 1 divided by 1 times 2 times 3, and then plus the next fraction 1 divided by 1 times 2 times 3 times 4, and so on forth forever and ever. That's where you get the letter E, or Euler's number is what it's called, okay? So on your calculator, there is a specific button for it. And so if you take a look at your button on your calculator, for those of you guys on Zoom, I'm gonna move it over to this. Hopefully I will remember to move it back. You hit second. And you're gonna go ahead and hit, do you see where it says division on your button? And it gives you that E number, okay? If you hit enter right there, it gives you 2.718. That's how you access that number. If you want an E button to like a 3rd power, you hit second, and you hit where it says LN. And do you see how there's like a little X on top? Then you could just put like a number 5, hit enter, and it's literally 2.71 times 2.71 5 times to get to that number, okay? So with that said, if I were to graph the parent function, y equals E, which is the same thing as y equals 2.718, 28, et cetera, because these 2 numbers are exactly the same. E is just equal to 2.71, blah, 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 okay? If I were to go and graph this to the x power, so like you have y equals e to the x, how would that look like? So And if so, if I were to do that, what will my chart look like? So I'm gonna have X right here, Y right there. For the X value, generally I just do 0, 1, and 2. For the Y value, you're essentially what you're doing is you're putting that number like Y equals e to the 0 power, Y equals e to the 1 power, Y equals e to the 2nd power. That's what you're doing, okay? And rather than doing that by hand or, by your calculator, it's easier if you use your TI 84 graphing calculator, so that way you can see how this is done. So let's go ahead and do that. Let's go back to the graphing calculator. Here's mine, and I'm going to graph it. So Y is equal to e to the X. So hit second, hit the LN button, and you get e to the X. And when I graph it, this is kind of what it looks like. It looks like it's touching almost to the Y equals 0, and then it just like shoots up, right? Like an exponential growth graph. And so as I'm looking at this right here, I'm going to go to second and then graph to the table function so that way I can put the numbers in. So when X is 0, you can see that Y equals 1. When X is at 1, you can see that Y is going to be at 2.7. When X is at 2, it kind of tells you where the Y is as well. And I'm going to go ahead and just paste it over here so I can see a little bit easily of what that's going to be. So then when I fill out my table, I can write that Y value here is going to be a 1. Y value for X equals 1 is a 2.718. And when X is 2, Y is a 7.389. For me to graph this, I'm going to go ahead and have, it looks like my horizontal asymptote is going to be Y equals 0. So I'm just going to draw a line like that. You can use your highlighter for it. And this is horizontal asymptote is Y equals 0. Okay. And then I'm going to need a few points here. And I know that with my chart, when X is at 1, so X is at 1, my Y value is at 2.7. So go up 1, 2, 2.7, right there. When X is at 0, my Y value is at 1, so it's right there. And when it's at 2, it's going to be all the way up here at 7. So then what I'm going to do is I'm going to go ahead and if you take a look at your calculator one more time, if you go up to like the negatives, like -4, -5, -6, do you see how it's always very close to 0? But it actually never approaches 0. Do you see that? So it doesn't become like a -1 or anything. It just gets closer and closer to 0. So what you should go ahead and take a look and notice with this is looking at this, when X approaches -infinity, your Y approaches 0 is what I will write. Okay. So then I'm going to go ahead and draw my graph and connect the dots here. And so it just looks something like that. Whoop, there we go. All right, let's go on to the next part. So for those of you guys on Zoom, make sure you guys have this down on your paper. And we'll go on to the next piece right here. All right, so now I want to talk about compound interest formula. So if you look at this for P, P is going to go ahead and stand for principal, which is going to be, principal is not like the principal of your school. It's a different type of principal. And this is the start amount, like how much money did you put into the account to begin with. R stands for rate, and this one always have to be in a decimal. So to move a percent to a decimal, it's 2 spaces to the left. N is going to be the number of times And the number of times could be compounded per year. Oh, no problem, anytime. And so if it's like quarterly, you know it's 4. You know if it's semi-annual, it's 2. If it's gonna be weekly, it's 52 weeks in a year. And daily is 365 days in a year. And I'm thinking, like, is there any other way that they can reword it? I think that's about it. Or okay, last one, monthly. There are 12 months in a year. And T is just time in years. All right, so let's take a look at this. If you have $1,000 and you want to put this into a bank account, that's going to give you a 5% return every single month for 5 years. How much money will you get at the end of the 5 years if you invest $1,000? So clearly I'm going to put this into that equation. So A equals 1,000, 1 plus the rate is 0.05 divided by N. Your N is going to be 12 because it's every 12 months, right? There's 12 months in a year. And then 12 times 5 for 5 years. You do have to insert this into your calculator according to PEMDAS. So parenthesis comes first, right there in yellow. Then you're going to go ahead and look at the exponent, which is right there in orange. And then lastly, you're going to go ahead and multiply the 1,000 in blue. Okay, so let's grab our calculators, because if we can use our calculators to do this and not have to do it by hand, all the better. All right, so first thing that I'm going to do is on my calculator, I'm going to go inside the yellow parenthesis. Okay, inside the yellow parenthesis, I have a plus and a divide. Well, you know divide comes first, right? So I'm going to do 0.05 divided by 12. That's my answer right there. Then I'm going to add the 1. So my multiplier is 0.00416. Now that I'm done with the exponent, or sorry, I'm done with the parenthesis, I'm going to go to the exponent, which is in the orange. So I'm going to push that little triangle button for the exponent. And then I'm going to do 12 times 5. So I know 12 times 5 is 60. So I'm push 60, enter. Now that I have that number, my last thing I need to do is the blue. So I times it by 1,000. And in 5 years, I get an extra $283 back, which doesn't sound like a lot, you guys, but if you do it for like 30 years, you probably get a lot more money. All right, so your answer is just simply going to be 1,200. $1,283.36 in 5 years. Okay, so that is the compound interest. Okay, next I'm going to talk about is continuous compound interest. So this will give you a lot more money because it's a continual compounding of the interest. So let's go and take a look at that question right here. It says, if you're to invest $950 and you're getting 3.5% back, you're going to put that money in for 14 years. 14 years and 3 months. Okay, so this one's going to be a little bit weird because how do you convert 14 years and 3 months into years? Well, you will have to convert 14, that's number of years, plus 3 over 12, because that's how many months out of 12 months in a year you have. So then that's going to be your T. So you just have to do a little bit of extra work, but that's okay because you can do it, okay? So on your calculator, I'm going to go back to my calculator. So those of you guys on Zoom, I'm just going to kind of transfer this over. We're first going to deal with the T. So I'm just going to do 14 plus what is 3 divided by 12? And you want to put parentheses around it so that way your calculator knows how to do PEMDAS, because even though it's a calculator, it doesn't have artificial intelligence, so it doesn't really know which comes first. So your T is going to be 14.25. That is going to be your T. Okay. So your T is 14.25. And now that I have all of this number, I'm going to plug it into this formula. A equals P, which is 950, E to the R is 0.035 times T, which is 14.25. And I know some of you guys are like, well, do I even have to like write this equation down? If you could do it in your head and on your calculator, then no, you don't have to. But I'm just doing this so that way you guys can see it, how this is written up. So now once I write this, I'm going to go ahead and plug it into my calculator. So then here's my calculator. I'm going to do 950 second, and I want to do the second with a ln because your E has an exponent. And then with your E, you're going to put 0.035 times 14.25. So you initially invested $950 in about 14 years. How much money do you get back? You get almost kind of double. So you get about $15,664 back. And it's important that you know how to do this on your calculator because on your test, on your final exam, you will have questions like this. And if you don't know where to use your calculator or the buttons, that will be a problem because I don't know about you, but I would not want to do this by hand because I don't think you will be able to. It's just going to be a lot of work and you don't want to do that. So your answer for this question is going to be $1,564.33. So not 15,000. But you still get a bit back. I mean, it's only $950 that you're investing. So if you can imagine like you're doing that every single year, you know, then by the time you retire in like 30 to 40 years, you should have this amount times 30 and 40, right? And that's how much money you'll get back. All right, so then we're going to go on to the next part. Okay, we're going to break this down a little bit better for you guys. Okay, yearly N equals 1. Quarterly N equals 4. Monthly is 12. Weekly is 52. And daily is going to be 365. Continuously, it's just that E value. All right, so let's go ahead and compare this, you guys, to see which one is going to give you most money for your buck when you retire and when you invest. So here you have P is $5,000. Rate is 0.03. T is 4. Your N is going to be different, or I can put varies because depending on which one you have, right? Your equation is going to be the same. So your formula they're going to be using for this is A equals 5,000, 1 plus R divided by N. N in this case is just 1, okay? To the NT, so 1 times 4. You want to plug that into your calculator. For your quarterly, it's exactly the same thing, but just make a note that when you guys do this with the quarterly, it's 4 and 4 times 4. Similarly, with a monthly, you get 5,000, 1 plus 0.03 divided by 12, 12 times 4. And then with the weekly, if you have a YouTube video on, it is very distracting. I'm not bothering you if you decide to sit there quietly, but please be considerate of other people around you. I would appreciate it. Thank you. Thank you. All right. And then, of course, daily is 365 times 4. And then, of course, your very last one with your continuously, A equals 5,000, e to the RT, which is 0.03 times 4. Those are the 1, 2, 3, 4, 5, 6 different equations you're going to plug into your calculator to figure out your answer. Sorry. All right, so let's go ahead and take a look at your calculator. And let's see how much money you're going to be making as a millionaire. All right, so let's start off with the first one. So you're going to have 5,000. And then I'm going to just go ahead and do, well, 1 plus 0.03 divided by 1 is just 1.03, right? And then 1 times 4 to the 4th power. So that's what you're going to insert on your calculator. And I hit enter. And I get about $5,627. So that's not bad. I mean, like, you're not getting a ton of money, but, you know, you're getting about $600 back in 4 years. That's not bad. Okay, so then let's take a look at the second one. For the second one, we're going to insert this into your calculator, and it's still like, you're going to start off in the parenthesis. So 0.03 divided by 4 plus 1, raise that to the exponent of 4 times 4, which is 16, then times that by $5,000. So with that one, you actually didn't get like a tremendous amount of money back. I mean, it's like $5,634. So it's not a lot more than the first one that we had. But it's still something. So yeah, still worthwhile. All right, so then in the green is the one that's monthly. And so then if I go ahead and type that into my calculator, I have 0.03 divided by 12. I'm going to go ahead and raise that to 12 times 4 is 48. Plus the, or actually, no, I screwed this up. I'm sorry, hold on. 0.03 divided by 12. I forgot to add the 1. That was my fault. Plus the 1. Then raise it to 48. Okay, then times it by 5,000. And you get a little bit more money, not nearly as much as I thought it would be, but you know, still something. You get about $5,636. Okay. And then the last, or the second, third to last one, which is in blue right here, you're going to go ahead and calculate that one. And we're going to do 0.03 divided by 52 weeks. Add it to 1, raise it to 52 times 4, which I can't do in my head, so I'm just going to multiply it. And that's your multiplier, times that by 5,000. Crap, I timed it by 50,000. So if you make a mistake, rather than doing all of that over, one of the tricks you guys do you see the little up and down arrow that I'm pushing on? If I push the up arrow, do you see how I can like highlight it in blue? If I want that number right there, I can go ahead and hit enter. It brings it down. So you don't have to retype it in. That's a little trick. Times that by 5,000 because I mess it up. Enter. And you get $5,637 back. And so I don't know about you, but like, it doesn't seem like money is really going that fast. It just seems like it's fairly, you know, consistent for the most part. Well, let's see if it makes a big difference if it's like daily. Okay. So then let's go back over here and I'm going to go ahead and do just 0.03 divided by 365 for the daily plus the 1, raise it to 365 times 4, which gives me 1.27 and then times it by 5,000. So again, not a huge change, but you still, you know, you're not losing money. So that's good. because sometimes when you play like the stock market, you do end up losing money, especially when the economy is bad. I know this year for my 401k, I've started a 401k. Actually I have a 403b and I also have 457 because I work for the state of Nevada, so we don't get to use a 401k. Since the Ukraine war happened and also with inflation, I think this year, and this year's not even, over yet, I lost about $7,000. But, I'm not retiring anytime soon. So my hope is that, by the time I retire in 6 years, that will get bounced back. And it will, because generally when you put it into an investment, you get about like 6 to 10% back every year, and that's why when you put in like $1,000 and you wait for 40 years, you'll probably get like $1 million back. Yeah. So you have to wait for that to happen though. All right, and the very last one is with the E. So this one, hopefully you'll get more money back. So you're gonna do 5,000. Second, ln 0.03 times 4. And this is what you get back. Okay, and so those are your answers, you guys, for your numbers. And I know you're like, well, it doesn't look like it's changing that much. Well, no, because it's literally there for 4 years. Okay, it's not going to change a lot if it's just 4 years. But if you could imagine your last question, like if I were to change that question so that instead of, and again, I'm using that little cursor thing for the blue, you can bring that equation down rather than typing all over. If you get 3% back, what if you put it there for 40 years? For 40 years, take a look at that. You're going to get $16,600 back if you get 3% return. If you put into like a 401k and stuff, generally you get about like 6 to 10%. Okay, so 3% is not a lot, but you get $16,000 back from 5,000, which I think is a pretty good investment. It like triples your investment. You know what I mean? So when you guys get a job and you can put your money into a 401k, make sure you do that because you don't want to be working when you're like 63 and over. And I know for some kids that I have, they're like, well, I work for the Amazon warehouse and they pay me about like $17 an hour, which is fairly good, right? But it's also a very labor intensive job. You guys are young right now, so it probably doesn't seem that big of a deal. But could you imagine if you're like 60 and you're still doing that? Like that's really back-breaking labor, So want to make sure you save your money, put into a retirement so that we can retire. All right, you guys, now we're going to go ahead and move on to this part. Which formula are you going to use for today's question? We're going to go ahead and apply it to some applications. So take a moment with your highlighter and highlight the important information there. And then figure out, which formula do I use? Because there's 4 of them. So how am I going to determine the appropriate one? Okay, so how much money your parent would have to need to invest in the time of your birth in order to have $30,000 for your college when you guys turn 18, okay? The investment is made semi-annual, so N equals 2 at a rate of 0.0275%, which is in decimals. 75. All right, so the question here is saying your P is going to be $30,000. Or I'm sorry, your A is $30,000, but how much does your parent need to put it when you're born? Okay, and the time is 18 because you want $30,000 to go to college when you turn 18, obviously. So given the fact that there is an N right there, you know that you're going to be using this formula right here because that's the only formula that has an N, obviously. All right, so let's use that formula. So A, which is 30,000, equals P, 1 plus the rate divided by N to the T power. So 2 times 18 is on top. So first thing to do is you're going to do this part in yellow. We're going to put that into our calculator. And then we're gonna go ahead and do the orange in the calculator. So let's grab our calculator then. Here's my calculator. You should have your calculator as well. And so what I'm gonna do is I'm gonna do 0.0275 divided by 2 plus 1, raise it to 2 times 18, which is 36. And you get a 1.6349, blah, 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 blah. Okay, so then what I'm gonna do is I'm gonna have 30,000 equals 1.6. I'm gonna round it 4p. Okay, because I'm replacing all of that yellow and orange with what I just found in the calculator. Well, how do you get rid of a times? Opposite of a times is gonna be a divide. So that's what I'm gonna do. So then with your calculator, you are gonna take 30,000 divided by, and rather than typing that entire thing, you just use the up button to highlight that part, hit enter, and then boom, there it is, right? That'll save you some time. It's like a little trick I teach my calculus kids. Hit enter. $18,348 is what your parents had to invest when you were born in order for them to give you $30,000 for your college classes. All right, you guys, that is it. I hope you guys have a wonderful week. I will see you guys tomorrow, and I hope you guys take care.